Okay, good day everyone. Welcome back to Qualitative Methods with Simulations and Modeling. And today we will be talking about the model development. And at this moment, we are going to talk first about the measures of uncertainty. So what this is all about. In fact, some of which we have discussed that when we talk about it in our in our inferential data manipulations and visualizations. At the same time, in our descriptive data analytics with visualizations. And so with this, we'll be more talking about what is measures of uncertainty. So what is a measure of uncertainty? Measures of uncertainty relates to how the estimate might differ from the true value. And these measures helps users of on statistics to understand the degree of confidence in the output. So many of our statistics rely on data collected from basically survey, and we are often interested in the characteristics of the population of people or businesses as a whole, but usually we survey a sample of population rather than everyone. We just get a sample from a population. And this is time liar and more cost effective. And if the sample is large enough and well designed, can lead to accurate statistics. Okay, using a sample means that our statistics can usually accompanied by measures of uncertainty. So these measures of uncertainties includes the standard error, the confidence interval, the coefficient of variation, statistical significance. So understanding the sampling and the effect it has on statistics is also important for interpreting these measures of uncertainty. So this standard error, okay, is actually the simplest measure of how precise a survey-based estimate is. So take note that the standard error can be used as a guide to help interpret the possible sampling error. So it shows actually how close the estimate based on sample data might be to the value that would have been taken from the whole population. So actually, it also measures or measured using the same units as the estimate itself. And in general, the closer the standard error to zero, the more precise the estimate. So smaller values shows a greater level of precision. Also, standard errors are also based on sample data, so are unknown statistics and are usually estimated themselves. So, for example, in this table, the non-financial business economy estimates are taken from the annual business survey. Okay. In this case, the standard error for estimates of various industry sectors is used to assess how precise total the turnover estimates are. And the estimates for education and water and waste management differ in size, as you can see in the table. However, the relative standard errors also shows they have similar levels of relative precisions, which is about like 0.01 or 1%. Okay, let's move on to the confidence interval. So, confidence interval or CI, we've been using these in our discussions and even in fact in our correlationals and interpretations of p-values and among others, okay, or relationships. This actually shows what the uncertainty is with a certain statistics. For example, a mean. The margin of error is a range of values above and below a confidence interval's sample statistics. For example, a survey might report a 95% confidence interval of between 4.88 and 5.26. So that means if the survey is repeated using the same methods, 95% of the time, the true population parameter will fall between 4.88 and 5.26, 95% of the time. So The mean error refers to the mean or average of all errors. Error means in this context is the difference between a measured and the true value. So in other words, a 95% confidence interval is frequently used in this case. So this means that we draw 20, for example, 20 random samples and calculated the 95% interval for each sample using data in that sample. So we could expect that on average, 19 out of 20 for a 95% resulting confidence intervals would contain the true population of value, and 1 in 20 or the 5% would not. So if we increase the confidence interval to 99%, so the wider intervals would be obtained. Okay, let's move on to the coefficient of variation. The coefficient of variation makes it easier to understand whether a standard error is large compared with the estimate itself. So the confidence of variation, or CV, is used to compare the relative precision across surveys or variables, and is usually known as a percentage. It is a unitless quantity and so allows us to compare estimates with different scales of measurements. It is also known as the relative standard error and is actually calculated by dividing the standard error of an estimate by the estimates itself. So similar to the standard error, the closer the coefficient of variation is to zero, the more precise the estimate is. So where it is above 50%, the estimate is very unprecise, and the confidence intervals around the estimate will effectively contain zero. So the coefficient of variation should not be used for estimates of values that are close to zero or for percentages. That's coefficient of variation. How about the statistical significance? So before we use the p-values here. So statistical significance help us actually to establish what observed changes or relationships we should pay attention to, and which apparent changes may have occurred only as a result of randomness in the sampling. So we can use statistical significance to decide whether we think a difference between two survey-based estimates reflects a true change in the population rather than being attributable to random variation in our sample selection. So as a result, it's said to be statistically significant is likely not caused by chance or the variable nature of the samples. So a defined threshold can help us test for change. So if the test of statistical significance calculated from the estimates at different points in time is larger than the threshold, so the change is said to be statistically significant. So for example, a 5% standard actually is often used when testing for statistical significance. So the observed change is statistically significant at the 5% level if there is less than a 1 in 20 chance of the observed change being calculated by chance if there is actually no underlying change. So within the commentary of our statistical bullet example, so we will actually avoid using the term significant to describe trends in our statistics, and we'll always use is statistically significant instead just only the term significant to avoid any confusion of our when we interpret the data. Next to that is the sources of uncertainty. So what are those? So we have the interpolation errors. It happens because of a lack of data and may be compounded by your choice of interpolation method. And also the model bias. It happens because any model is an approximation or a best guess at what a true distribution might look like. And also the numerical errors, which are human errors that creep in when translating mathematical models into a computer. Another one is the observational error, which is due to the variability of measures in an experiment. Another one is the parameter uncertainty. This happens because we don't know the exact or the best values in a population. Now, we can only take a good guess with a particular sample. All right, so that's all with about uncertainty. So these are the references that I would like to also acknowledge. The Office of the National Statistics websites, this is how-to websites, and finally, the Statistics Knowledge Portal. Thank you very much. That ends our presentation.